Test. Um, test. Test. Okay. So today we will be covering chapter 1.3, which is going to be the average rate of change. This will be a two-part because the second half will be relevant uploaded later. Don't worry about it. Okay. So first, let's define what the average rate of change is. Okay. I'm going to shorten it to average ROC, which is just rate of change. Okay. So the average rate of change is going to be defined as a function. You can call it f of x um, on, ooh, just kidding. The average rate of change. So first we'll define a couple things. One, let our function be f of x. Two, we're going to define it on or over the interval a comma b. Then the average rate of change of f of x over a comma b is going to be delta y over delta x. These triangles are called deltas. This can be read as change in y over change in x, basically rise over run. And it's going to be defined as f of b minus f of a all over b minus a. Yeah, that's it. Obviously, it has to be defined at a and b, or else you can't do that. Yeah, that's it. And it's a great way of approximating slope of different functions over some interval. Okay, so like if you have like a, b, f of b, f of a, then you can kind of eyeball the slope, right? Change of a, change of b gives you a line that does something like that. And it's not bad. It's not bad, right? So let's do an example really quick. So for example, let's say you have a function f of x is equal to x minus 1 squared over 1 comma 5. So this one we'll do together, okay? You'll say, oh, that means f of 5 minus f of 1 over 5 minus, oops, 1, which is going to be, again, parentheses are important, okay? Do not lose them. This is going to be 5 minus 1 squared minus 1 minus 1 squared all over 5 minus 1, which is going to equal 4 squared minus 1 minus 0 squared all over 4, which is going to equal 4. Reasonable, I think. So now what I'm going to have you do is I'm going to have you try to do that over 0 comma 2. Okay? So I'll give the video a quick pause, work it out, and then, yeah. Okay, so if you're seeing this, you already tried it. So if we work it out, we'll have f of 2 minus f of 0 all over 2 minus 0. I'm going to drop the outer parentheses because I don't make as many mistakes with this business. Um, you can as well, as long as you're not saying stuff like, oh, f of 2 over 2 minus 0 minus f of 0, okay? That would be bad. So f of 2 is going to be, let's see, this part you do need parentheses. 2 minus 1 squared minus 0 minus 1 squared all over 2 minus 0, which is going to be 2 minus 1 is 1 squared, minus negative 1 squared all over 2, which is going to be 1 minus 1 over 2, which is 0. Hmm. Wait a minute. Let's see. Let's take a look at that function, yeah? The function is x minus 1 squared, so it's a parabola where the vertex is at x equals positive 1 and y equals 0, right? Because it's in the form of f of x equals x minus h squared plus k, or ax minus h squared plus k, right? And this is why I insist you guys know how to use parent functions, because you can kind of sanity check your work. Okay. And that means that f of 0 is 2, is 1. So it's going to be here. And let's say 2 lives here. This is, of course, 0, which means your parabola looks a little bit like that. And it's like, sure, yeah, the average rate of change is, in fact, 0, right? It started and ended up back where it started, horizontally at least. But, like, I don't know. Huh. Okay. Okay. Let's try it again. Let's try to approximate. Let's eyeball, okay? Let's eyeball the slope for x equals 6. Okay? Give that a pause and see what happens, right? Like, all you have to do is, you can do averages. So, like, you can choose an interval and just kind of like that, and it'll average out nicely, right? Like, that's what happened over here, right? And you can be like, oh, yeah, that's like the eyeballish slope of like here, right? Okay, so give that a go and we'll loop back. Okay, so we want the slope at x equals 6. So I'm going to choose my interval, okay? So I'm going to choose 6 as my lower number and then 7 as my higher number, okay? So big picture, I should be doing something like, let's say 6 lives here, 7 lives here. Let's see. Actually, that's probably not a great graph. Oh, 1, 2, 3, 4, 5, 6. All right, we'll just do this over. Okay, so big picture, right? We're gonna have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just so we have some extra numbers, our vertex lives here, right at 1. And we want the slope in this vertical area, right? Okay, so as we established earlier, at 1 comma, at 1, you live here. At 0, you live here. So let's call this 1. At 2, you live here. At 3, let's see, f of 3 is equal to 3 minus 1 squared, which is 4. Let's see, 1, 2, 3, 4. And then at 6, you have 6 minus 1 squared, which is 25. Let's say 25 lives up here, right? And then at 7, you have 36. So 36 is like up like here somewhere, right? Okay. No. So we know that the slope is supposed to look kind of positive-y, so that'll be a good sanity check if we goofed up. Oh no, what the hell happened here? Okay. Well, run that back. Oh goodness. Anyway, parabola looks vaguely like this, right? Okay. So if we approximate it, we'll get, oh, f of 6, 7 minus f of 6 is over 7 minus 6, which is going to be 36 minus 25 over 1, which is 9. Uh, and something is wrong because I don't think you got the same answer I did. And I imagine that might be because you didn't choose the same number as I did, right? Okay, well, let's talk a bit more about approximations then. If we have, let's see, let's talk some approximations. One, is approximating a good idea, right? And what we're going to do is we're going to review here. Was approximating okay here? Does that slope look kind of okay-ish? Was approximating great here? Was approximating good here? And what I'm going to say is I don't think it is. Because when you approximate, right, what ends up happening is if I choose something different and you choose something different, we'll end up with different answers. Not great. Two is eyeballing different intervals a good idea. I'm also going to say no to that, right? And the reason is because, again, it goes back to here. If we eyeball and we eyeball differently, we might get inaccurate results, we might get different results, and sometimes you'll get wrong results, right? Let's say you're trying to approximate the slope here and you're telling me it's 0, right? And so lastly, I'm going to ask, what kind of intervals behave best? Bigger or smaller? Okay. In this, I'm going to leave as a cliffhanger because we will come back to it in the next lecture. Okay? Thank you for your attention. I will trim this up and make it lovely.